Hello, so we are going over our amount of substance homework, assignment number 2. If you want to test to see how you have progressed after getting the feedback, you can pause the video at various points and try the question again before seeing the answer. So question 1, we have an alkane containing 30 hydrogen atoms per molecule. What's its empirical formulae? So it's B, and we know this because the general formula of alkane is CnH2n plus 2. So we know it must have a molecular formula of C14H30. A lot of people make the mistake of selecting that option, but we want the simplest whole number ratio because we want the empirical formula, so that is C7H14. Question 2, which sample contains the most molecules? So you're going to have to work out the number of molecules for all of them. So you need to know the moles of everything if we've not already been given the molecules. So the answer is A, but you do need to check the other ones to verify it. So answer A is given a molecule, so we don't need to do any converting. But B, we need to convert into moles. C and D, the same process. You can see that on the slide there. And we can see that A has the most. So this one's an empirical formulae question, and we're told that the new product has 68.9% chlorine in it. So the answer is D, but how we work that out was by going through it step by step. So if we've got 68.9% chlorine, then 31.1 must be titanium, and then we can work out the moles, and then we can divide those by the smallest number to get our whole number ratios of 1 to 3. Number 4 then, again the same method that we used last time. So we're going to plug those numbers in, and we get down to 1 to 2.5, so it has to be whole numbers, so we double that, and it's N2O5 then. So question 5, compounds containing Cu2+, OH- and CO3 2- ions are sometimes described as basic copper carbonates. Cu2, OH2, CO3 is added to an excess of dilute hydrochloric acid. A solution of copper-2 chloride is formed together with the two other products. Write an equation for the reaction. So you get a mark for identifying there's going to be water and carbon dioxide, and then you get second mark for balancing it. Now on part 2 they ask you to make an observation. What can you see? So a few people are liable to say we see CO2 forming. Well, you don't know it's CO2. What you do see is bubbles or fizzing or effervescence. You can also describe a solid disappearing, and you can also describe a blue-green solution forming. You do not need to say all 3 for the mark. So 5b part 1 is a simple definition. What is meant by the term empirical formula? So it's the simplest whole number ratio of atoms of each element in a compound. So those underlined words are essential. They did allow you to substitute atoms for copper, hydrogen, oxygen, given in the context of this question. Next we have to calculate the empirical formula of basic copper carbonate. Now from the beginning of the part B we're told how much carbon, hydrogen and oxygen is, and we're told the total mass of copper carbonate, so we can also work out the copper. A few people missed out working out copper, and so the rest of their questions, their workings end up being wrong. So you include copper, you work out its mass by taking 5, take away the masses of carbon, hydrogen, oxygen in the compound. We then work out the moles, we then divide through by the smallest number, and we've got here copper's 1.5, carbon's 1, hydrogen's 1, oxygen's 4. Now it needs to be simplest whole number ratio, so we're going to have to double all those, and we get the formula Cu3 C2H2O8. Now in this question they're quite forgiving. If you've got the right ratios and they're whole number ratios, you've got the mark, but quite often mark 3 or mark 4 is for stating what the empirical formula is, so please don't forget to do that when you try these questions. This is a very complicated multi-step calculation, so do take time to read carefully the information you've got in front of you. Going through this then, where do we start? Well, we know they've done a titration, and we know about the concentration and the volume of sodium hydroxide, so we can find out how many moles of sodium hydroxide there were. if we know how many moles there are of sodium hydroxide, then we know how many moles of HCl there is in this 25 centimetre cube sample. So they have a 1-to-1 ratio. That's going to be the same number. Now, they want you to spot. We made a whole flask, or we had a whole flask of 250 centimetre cube. We only took 1/10 of that to titrate against. So we need to know how much within that original volumetric flask. It's going to be 10 times that number, 0.0243. So we now know how much HCl we had. We can use the moles of HCl to work out how many moles of ZCl4 there were. As they reacted, or we have a ratio of 1-to-4 in this equation, looking at the one we've been originally given, we just need to divide the moles of HCl by 4. So now we know the moles of ZCl, we can work ZCl4, pardon. We can now work out the MR. That's going to be mass divided by moles, and we get the number 214.7. So what's the AR of Z? So we know we can look up what chlorine is, so we can take away the chlorine, and that leaves us with the number 72.7. And so what is Z? Using your periodic tables, you'll see that it is germanium. Now that is group 4, and you should have seen the structure ZCl4 and had the idea that it was going to be a group 4 element, because chlorine's -1 charge, and we've got 4 of them. That gives you an additional clue. So we have a simple reaction set up. We've got some ethanoic acid, also known as vinegar, react with some magnesium, and we're measuring the rate of reaction by measuring the volume of the hydrogen produced. So the first question asks you, with the aid of calculation, show that the magnesium is in excess. Now there's many ways of approaching this, but basically we want to use the information we were given at the start. So we've got a mass of magnesium and we've got a volume concentration of ethanoic acid, so we can work out the moles that we have at each of those, and using the ratios they react with, shown in the equation, we can see which one we have in excess. So here's one method: work out the moles of the ethanoic acid, and then see which one's in excess. So you can say that with the moles of magnesium there is 0.0163, so you need double that for the ethanoic acid, and clearly we have much more magnesium available, so that is in excess. The last question, people were reluctant to do a bit of a calculation on this one, but it was necessary. So this reaction and the volume of hydrogen is specific. That drawing is quite accurate to the volume of hydrogen produced. You're asked to draw sketch a line on for slightly different conditions. So you need to look at the volume of hydrogen that is produced, and you'll see that it is less. And you can work out how much less it is too. And that, hence that line is levelled out on the 8th line, not the 9th one. That is deliberate. You can also see that the concentration is higher, so it's going to be a faster rate of reaction, so we're expecting to see a steeper curve too.